In this video, we are going to find a term of an arithmetic sequence when the summation formula is known. It's given that the sum of the first n terms of an arithmetic sequence is n squared plus 4n. We need to find the eighth term of the sequence. Some of you may mistakenly think that n squared plus 4n is the general term of the sequence, but it's not. It's the summation formula. That means we cannot find the eighth term by substituting n equals 8 into the formula. Then how do we find it? Let Sn be the sum of the first n term of the arithmetic sequence first. We can find the nth term by finding the difference between Sn and Sn minus 1. Do you know why? Let's use the eighth term in the question to illustrate. By definition, S8 is the sum of the first 8 terms of the sequence, right? Then, focusing on this part of the expression, what's this? Yeah, that's S7. So we can rewrite S8 as the sum of S7 and the eighth term. In other words, the eighth term is equivalent to S8 minus S7. Can we find S8 and S7? Of course, just put 8 and 7 into the summation formula, and we'll get 96 and 77 respectively. As said, the eighth term equals S8 minus S7, so it's 96 minus 77, and the answer is 19. In fact, we can also find the general term of the sequence from the summation formula and then find the required term. Again, let Sn be the sum of the first n terms of the arithmetic sequence first. So, Sn will be equal to T1 plus T2 plus T3, so on and so forth until Tn minus 1 and Tn. Similarly, Sn minus 1 will be equal to T1 plus T2 plus T3, so on and so forth until Tn minus 1. Subtracting Sn minus 1 from Sn, the difference will be Tn, which is what we want to find. Putting the summation formula into the equation, we get this. Simplifying it, the general term is equal to 2n plus 3. Therefore, the eighth term of the sequence is 2 times 8 plus 3. That is 19. So this is a way to get the same result by finding the general term first. That's it.